All right. Fine then. Today there are pending topics actually that I am targeting. We'll see. What are all pending topics, boss? This is 12. So the very first one today, what I'm targeting, no, gradient descent algorithm. I am not done, right? We are not done, right? Yeah. Gradient descent algorithm. And the next one is bias and variance. Bias and variance. We'll see respectively. Date, file number. All right. Simple. I'm sure we done this. Can I change this? So this is a running topic. And k-means clustering we done. Even after gradient descent algorithm, we'll see. I'm going to cover another topic actually. Yeah. Come on. I just wanted to hear from you. Can you, I hope you already know. We already having the steps actually, but I just wanted to hear from you. Kindly please reply for two things actually. The first one is a ML steps. Next one is a ML flow. ML flow. So based on these two topics only, that today we are going to cover. So welcome back again. Good evening, everyone. Yeah, online team, can you hear me? Online team, we are going to start the session. Come on, sir, quickly. Okay, thank you. You tell me what are all ML steps. First step is a very good. The first one is what exactly? Importing libraries. No matter whatever algorithm, the steps are common actually. Second one is a loading the data set. Loading what exactly? Data set. Third one is data preparation. When I say data preparation, can I say X and Y? Very good. Can I say input and output actually? Input and what exactly? Output. Input and output. Remember that? Important actually. After data preparation, next step is a splitting the data set. Splitting the data set actually. Now, when you're saying about the splitting the data set, tell me X train, comma, X test. Next one is Y train. Next one, Y test. Y test. That's it. Now the next one is, tell me, sir, model creation. Next one is model training. And next one is prediction with the model. Prediction with what exactly? Model actually. Good. These are all ML steps actually. These are all what exactly? ML steps. Tell me the flow, sir. Data. Next one is a data frame. Next one is, come again. Feature engineering. Next one is array. Next one is what exactly? Machine learning algorithm. Under machine learning algorithm, what is the topic name? Very good. Gradient descent algorithm. Today we are going to cover this topic. Gradient descent algorithm. Under gradient descent algorithm, one more topic we do have. What is the topic, hold on. Gradient descent algorithm. We don't have that much time. Next one is what exactly, sir? Cost function. What exactly? Cost function. Good. Let us continue with the discussion. Today, if anyone came just now, repeating again, today the topic name is called as a gradient descent algorithm. What is the topic name? Gradient descent algorithm. Complete theory. Complete what exactly? Theory. Step by step you need to understand, but I'm sure the most interesting theory actually. Good. Sir, let me tell you. When I'm talking about the gradient descent algorithm, this algorithm will work during training. This algorithm will work at what step actually? During training. Good. Let me take these are all steps. Now, hope you understand. Gradient descent algorithm here it works actually. Gradient descent algorithm here it works. Here it works. And how it works, I will tell you step by step. Repeating again. Generally, client will give the data set. From the data set, we need to create a data frame. We need to create what exactly, sir? Data frame. From the data frame, in between, if required, what we need to apply? FE means feature engineering we need to apply. I hope you know. Please don't ask what is the feature engineering. Next one, even though you applied feature engineering, maybe chance you may get a array actually. No matter what, either it is a array or a data frame. Finally, we need what exactly? Array. For machine learning, always the input is what exactly, sir? Array. No doubt in that. Just you have to remember, if you're taking this one, let me just try to take this one. Yes, of course, from input we are creating a data frame. From data frame, we are getting a feature engineering. From feature engineering, we are getting what exactly? Array. This array will be input to whom actually? ML algorithm. For ML algorithm, the input should be array. For ML algorithm, the backend algorithms was designed in such a way that it accept only arrays. It accept only what exactly? Even though if you are giving data frame, slightly it will throw warning. I hope you know we have seen that one also. Good. Sir, once we have given this array to the ML algorithm, then automatically what happened, backend training will be start, sir. ML algorithm will take the data. ML algorithm will take what exactly? Data. Then backend ML algorithm, we created an ML algorithm, a kind of not from scratch actually. Just creating an object to ML algorithm is nothing but we have created an algorithm actually. Once we have given array to the ML algorithm, backend who will involve, tell me? Gradient descent algorithm will involve. And for gradient descent algorithm, again it depends upon one more topic. What is the topic name actually? Cost function. One more time, what is the topic name? Cost function. Let me tell you why these are all being getting involving. A single ML algorithm will not work entirely actually. Definitely it needs support. That support is nothing but a gradient descent algorithm. For that one, cost function. Let me tell you what is the purpose of this one. And here patience really matters. I would like to compare with linear regression. I would like to compare with what exactly? Simple linear regression. I'm sure everyone knows about this. Am I right? Simple linear regression. Tell me the formula, sir. Y equals to mx plus c. Thank God I asked only simple linear regression. Am I right? Yeah. This one also you are not responding. Tell me, when I'm talking about here y, what is this value actually? Target. Can I say that? Tell me, sir. Target or output actually. M, any idea? M means coefficient. What is this one? Coefficient actually. Coefficient. And x means input. X means what? Yeah, very good. Somebody told. Don't scold actually feature. And the C means what exactly, sir? Intercept. C means what exactly? Intercept. Keep in mind that now, frankly speaking, this is called as a parameter. That is called as what exactly? Parameter 1. And second one is called as what exactly, sir? Parameter 2. Parameter 1. Next one is what exactly? Parameter 2. Sir, once you have given the data to the ML algorithm, ML algorithm backend it will go to the gradient descent algorithm. Gradient descent algorithm will start the calculation M value and C value. What values actually? M values and C value. Hold on. Let me just try to hold on. I just wanted to show you one diagram. Let us try to understand slowly by slowly, please. First of all, let me open the material. Gradient descent algorithm exactly here. Yeah. Can somebody tell me the main motto for cost function is what exactly? Main motto for cost function. Very good, man. What is the main motto actually? Reducing the error. Reducing what exactly? Error. One more time, can you please repeat again? The main motto, the main purpose of cost function is reducing the error. Reducing is what exactly? Error actually. If I say cost function, no doubt at all, automatically gradient descent algorithm also. What is this one, sir? Gradient descent algorithm. I will read slowly by slowly, and even parallelly I will show diagrams also. We have to map step by step. Come on, sir. Gradient descent algorithm is a optimization algorithm. Gradient descent algorithm is what exactly it is? A optimization algorithm. Let me tell you. Simple linear regression we have implemented. Even multiple linear regression we have implemented. Just recently KNN we have implemented. But let me tell you, gradient descent algorithm is a inbuilt. We no need to implement. But how it is working, you need to understand. I am repeating one more time. Till now, we have worked with logistic regression, multi-class classification, simple linear regression, multiple linear regression, and blah blah, KNN. These are all many things we have seen. Even SVM also we have seen, decision tree we have seen, random for sir, are we seen? Tell me, sir, please. We have seen actually. Good. A bunch of algorithms we have seen till now. A group of algorithms. These are all algorithms we have implemented. We have created actually. But when it comes to gradient descent algorithm, the very first point is we no need to create a gradient descent algorithm. By default, for every algorithm, gradient descent algorithm will give a support actually. Conclusion of the story, it is a predefined algorithm. What algorithm, sir? Predefined. It is inbuilt actually. This algorithm is helping to the existing algorithm to reduce the error value. To reduce what exactly? Error value. Keep in mind that. Right, good. Gradient descent is a optimization algorithm. What algorithm? Optimization. I mean to say that. What do you mean by optimization? What to increase, what to reduce, it knows very well. What to increase, what to reduce, it knows very well actually. Right? And this algorithm finds the values of what exactly? Parameters. What is that one, sir? Parameters of a function that minimizes what exactly, sir? Cost function. I mean to say that, you know, I will explain with practically, sir. Hold on. This line I will explain with practically. Go back and even here you need to spend some time. Please understand this one. Let me drink water. Spend here some time. Understanding from here. First of all, 200 iterations. Started from first iteration, second iteration, third iteration. And y equals to mx plus c. Y equals to what exactly? Mx plus c. Come on, one more time. Y equals to mx plus c. That too, did you notice m value and it is keep on changing? B value also slowly it is changing actually. This is something like a tuning. This is something like what exactly? Tuning. Initially, m values are, what is initial value? Did anyone notice actually? Come on, very good. Tell me. Initially, m value and b values are called as a parameters. Initial values are zero, man. Initial values are what exactly? When initial values are zero, did you notice the line is exactly something like a horizontal line actually? Did you understand, sir? Yeah. But instead of horizontal 0 0 value, slowly it happened, it increased the value. Again, it was plotting the line. Again, it is increasing the value. It is plotting the line. Again, it is increasing the value, plotting the line. At certain point of time, these parameters are fixed actually. These parameters are what exactly? Fixed. Did you understand? If you didn't understand also, no worries. I will explain. Hold on. Let me take one example. Very nice. Then I just wanted to take one example. What is that example, sir? Simple linear regression. Important, boss. This is very, very important. I need your attention actually. Sir, I hope you already know a kind of one example. That example will be predicting price for what exactly? Area. One more time. Predicting price for what exactly? Area. There is a formula, right? Can we capture that formula? Yeah, very good. Now let us just try to capture this formula, sir. Price equals to m into area plus b. Now kindly please hold on, please. Look at my screen, everyone. The formula, simple linear regression. Simple linear regression. Then there is a formula. The formula will be price equals to, what is this value? M into what exactly, sir? Area area plus what exactly? B. Area plus what exactly? B. Here, sir, what exactly happened, first it will take this function actually, it will take this formula, it will take this what exactly formula. Then uh, initially in a first step, what exactly, let me take m value comma b value. What values actually? First I'm taking the total function, I mean to say that the formula. In a second step I'm taking m value and b value. Once we have taken this m value and b value, no doubt at all, we are going to calculate target variable. We are going to calculate what exactly? Target variable actually. Am I right or not, sir? I mean to say that m value, b value, area value, you can substitute, and here you can get what exactly? Price. Price means nothing but what exactly? Target value. Sir, now before calculating target value, then what exactly it will happen? I'm sure you know very well, and it will do the prediction for target value. Then here it will calculate error value. It will calculate what exactly? Error. Any idea what do you mean by error? Come on, one more time. Yeah, the error value means difference between actual value and predicted value is nothing but a error value. Right, good. Go back. Don't worry. Don't worry. Go back to the cost function. And here, what do you mean by bias? Yeah, residual. Good. One or two topics, it is interlink each other actually. Did you notice here? First of all, what exactly happened? This is the model. This model is telling, "Arey boss, I done prediction. I done what exactly? Prediction. This prediction backend it is done by substituting m value and b value. M value and what exactly? B value. Then finally, it got a some predicted value. Once it is getting predicted value, finally, cost function, what it is giving, any idea actually? Error it is giving. What it is giving? Error it is giving. Did you understand? Good. Repeating again. First of all, there is a math formula. From this math formula, definitely there are values. What are values? M value and B value. Initially, sir, initially it will take some 0, 0 values. What values actually? 0, 0 values. This is called as a parameter, sir. This is called as what exactly? Parameters. Parameters. Initial parameters will be 0. Once it have taken initial parameters, then with these initial parameters, it will start prediction. It will start what exactly? Prediction. Once it is done the prediction, then it will calculate the error value actually. It calculate what exactly? Error value. Sir, here ensure that 2 points are important. If next one is the else actually. If next one is the else. What is the if If error is a bigger value, error is what exactly? Error is big value. I'm sorry, man. Error is small value. Error is small value. Parameters are good. Parameters are what exactly? Good actually. Now else means what exactly? Any idea? Come and tell me. Error is not a small, something like, error is a big value actually. Error is what exactly? Big value, big value, big value. Then here what exactly, update the parameters. Update what exactly? Parameters. And, repeat the process one more time. Repeat what exactly? Repeat the process one more time. Process one more time. This process will happen until at what? Any idea? Until the error reaches to what exactly? Small value. Until the error reaches what exactly? Small value. Hold on. Now I'm sure till now if you understand the explanation, from here whatever I'm explaining, I'm sure you will understand, sir. Now go back. Now kindly please observe this one. How gradient algorithm will work in a backend, First of all, it is starting with random initial value for the parameter. Step number one. Step number one. Gradient descent algorithm, how it is working. Gradient descent algorithm, how it is working. The very first step is first one. It takes random initial value. What exactly actually? Random initial value. Initial values. Something like, m equals to 0. Next one is what exactly, sir? B equals to 0. Can somebody talk with me? M equals to 0. Next one is what exactly? B equals to 0. Can I say random values actually? Yeah, good. It takes random initial value. Then what exactly it is doing, once it has taken random initial value, predict the value of the target variable using the current parameters. Step number two, immediately what exactly happened, doing prediction with parameters. This initial values is also called as a, parameters. It takes random initial values for the parameters. For the parameters. for the parameters. When I say parameter, m equals to 0, b equals to 0 actually. Come on. Can somebody read everyone actually? It takes random initial values for parameters. When I say parameter, talk with me. M value and what exactly? What is M? Any idea? Coefficient. One more time. What is a B value? Intercept actually. Good. Even look at this diagram. Look at this diagram. M value and B value keep on changing. But initially it was started with what exactly? Some 0, 0. Good. Hold on. Go back to the next one. You know, with above parameters, I mean to say this, algorithm will do prediction. Algorithm will do what exactly? Prediction. Come on. First one is what exactly? Random initial values it will take, sir. With that random initial value, what exactly happen actually? Prediction is happening. Tell me what exactly happened? Prediction. Sir, wherever prediction came, step number 3, please look at my screen actually. In step number 3, what exactly happened? Calculate the cost value. What do you mean by cost? Any idea? Do you think 10 rupees cost, 20 rupees cost actually? What is the cost? Very good, man. Calculate the cost. Calculate, calculate error value. What value actually? Error value. Good. Come on, repeat one more time. What is the step number 1, sir? In gradient descent algorithm, it takes random initial values for the parameters. What do you mean by parameter? M equals to what exactly? 0. B equals to what exactly? 0. With these two values, it will do the prediction. It will do what exactly? Prediction. Once the prediction came, and cost function knows actual value. If you want to go back and look at this material, cost function knows actual value. Like this, you need to map actual. Good. Then, go back to the next one. Calculate the cost value for step number 3. Is cost minimized? Here, condition number 1. Step number 4. What is the step number? Is error is small? Error is what exactly, sir? Small value or not? Value or not? Here the condition is happening. Now conclusion of the story. If small, if what exactly, sir? Small, the taken parameters are really good. The taken parameters are what exactly? Parameters are really good actually. Then stop training. Training will be stopped immediately actually. Then go for the end. Then the process is end actually. Process is what exactly? Process is end. Now, elif. Elif means what exactly, sir? If error is small, let me write like this, right? If error is not a small means what exactly? Error is big. Error is what exactly, sir? Big. Can somebody talk with me in this scenario? What exactly happened? Think logically. Hold on, let me repeat the total process one more time so that you can connect actually. Please, I need your attention actually. I will explain 2 to 3 times. Damn sure interview question. During interview, you no need to explain what is a gradient descent algorithm. These are all things actually. Just explain these steps enough. I mean, you will get an idea actually. Conclusion of the story. Go back and give a small revision. If anyone came in between to the session, please focus, sir. If anyone came in between the session, today topic name is a first of all machine learning. I hope you're a regular student actually, right? In a machine learning, would you have a topic? The topic name is called as a gradient descent algorithm. What algorithm? Gradient descent algorithm. Yeah, good. This gradient descent algorithm belongs to model training topic. What topic? Model training topic. I hope you already know the steps, ML steps: importing libraries, loading the data set, data preparation, splitting the data set, model creation, model training, prediction with the model. Good. Now, I hope you already know model training. During model training, this is an invisible step actually. This step is a hidden process. Backend someone will involve. That backend person name is called as a gradient descent algorithm. Who will involve actually? For again the backend gradient descent algorithm, one more backbone is called as a cost function. One more backbone is called as what exactly? Now the today discussion, hey Daniel, explain how the gradient descent algorithm is working. How GDA is working. GDA is working actually. That's what I'm trying to help you. Good. I hope you know the process. What is the process? Generally, till now, what exactly we done, sir? We have taken the data. We have taken what exactly? Data. Then we have created a data frame. We have created what exactly? Data frame. Then we applied a feature engineering. We applied what exactly? Feature engineering. Then we created a array. Then we created an algorithm. We created what exactly? Algorithm. Started training. Started what exactly? Sir, during this training, these steps are happening. At what time it is happening actually? During training. During training the model. Once the model training started, once the model training started actually, below steps are happening exactly. Below steps are happening exactly. Happening. What are below steps? Immediately, once you started a training actually, let me ask you a question. To start a training, what we need to do? Come again. Very good. We need to call a method. Method name is called as what exactly? Fit method. Sir, when you call a fit method, exactly, now the game is started actually. What is the game? Gradient descent algorithm will come. And the gradient descent algorithm will say hi to the linear regression actually. It's okay. You can take a chair actually. Here onwards, this is my part actually. Now gradient descent algorithm, it will take the math formula actually. No doubt at all. Every formula, it is having parameters. It is having what exactly, sir? Parameter. Good. First of all, what it will do, it takes random initial value for the parameter. Exactly, it is happening. M value equals to 0, B value equals to 0. Even this diagram also saying the same thing actually. Am I right? Good. Once the parameter came, then why parameters are? These parameters are helping in a prediction. These parameters are helping in where exactly, sir? Prediction. Come on, talk with me. Helping in where exactly? Prediction. First to step, what is the word you need to remember? Parameter. One more time. Parameter. By using these parameters, we are doing what exactly? Prediction. Sir, once the prediction came, then what we can do, we can calculate the what exactly? Error value. Come on, first word is what exactly? Very good. One more time. One more time, sir. Parameter. Second word is a second word. Third word is error value. Good. Once the error value came, who will calculate error? Yeah, very good. Gradient descent algorithm will call, hey, cost function, calculate the error value. Then cost function will calculate and it will tell to the gradient descent algorithm. Now, gradient descent algorithm, something like a CA person actually, it will map out. Is it small value or else is it bigger value? I mean to say that. Go back. I will show you the small diagram. Sir, gradient descent algorithm is seriously very nice, sir. Take this one and you can just try to add here. Yeah, good. I hope I already told, sir. Here the error always the bigger error actually. Error, assuming that here the error value is what exactly? 100. What is error value? 100 actually. Good. But here, what is error value, sir? Any idea? Let me just try to tell. Here the error value is something like a 2.5. What is the value? 2.5. Yeah, good. What exactly happened, whenever the gradient descent algorithm, first time it takes the parameters. Yes, exactly. Calculated actually. Is error is small or not actually? First time it will cross verify. If error is really small, frankly speaking, just for one iteration, it is not a small. No doubt at all. If error is a small, if error is what exactly, sir? Small. Good. Error is small or not? Error is small or not actually. If error is small, the taken parameters are really good actually. What is the taken parameters? These are all very good. And the process is end. Training will be stopped actually. I mean to say that, no training is required. Training stopped. Training what exactly? Stopped. That parameters will give to the ML algorithm. Now ML algorithm is ready. With that ready algorithm, we are doing prediction. With that ready algorithm, we are doing what exactly? Prediction. Am I going speed actually? You are able to connect, right? Good. Sir, ELIF. ELIF means I hope error is what exactly? Big. If error is big, what is the process? The taken parameters are worst actually. Am I right or not, sir? Then what we need to do, we need to update what exactly? Tell me, parameters. We need to update what exactly? I mean to say that this one. Okay, good. Again, what it will do, let me explain. Hold on. Small change actually. 0.1 it will change. And here it will give 0.01. 0 point what exactly? 0, 1 actually. Previously, first step, what is the value, sir? 0, 0. Now, what is the value? Sir, what exactly happened? Again from here onwards, all steps will be happen actually. Conclusion of the story. Again, come here. Here, what is the step number 1? Can somebody tell me? With these parameters, it will do what exactly? Prediction. No doubt in that. What is the values here actually, sir? Talk with me. This is the value. Oh, sorry, man. Let me take this value. I will explain 2 to 3 times. I need your, attention actually. Good. With these parameters, it will do the calculation. Calculation in the sense prediction. I hope after prediction, what is the next one? Any idea? Very good. Calculate the error value. Calculate what exactly? Error value actually. I'm sure you will understand. Calculate what exactly? Error value. After calculating error value, what is the next step actually? It will cross verify one more time. It will cross verify what exactly? One more time. What is that one? Is error is a small or not? Is error is what exactly? Small or not? No doubt at all. This is happening actually. Let me just try to write slowly. If error is a small, you tell me, sir. If error is what exactly small, what exactly happened? The taken parameters are really good. What is the parameter here we have taken? Any idea? Tell me 0.1. Very good. Next one is a 0. Team, you know what? You guys are really understanding well. Why? Because this is a too difficult topic actually, but I'm getting a nice response from you. Once the parameters are good, do we think training is required actually? No, training will be stopped. But let us go for another scenario. What is the scenario actually? Else error is big. Else error is what exactly? Big actually. Then you tell me the step actually. First of all, the taken parameters are what exactly? I mean to say that bad. That word I should not use, just for fun I'm using actually. The taken parameters are not a good, sir. The taken parameters are not a good actually. I mean to say that good. Then what we need to do? Update the parameters. Update what exactly? Parameters. Parameters. Hold on. I have a one question for you. We need to update the parameter. We need to update the. Sir, previously, what is the values actually? Can somebody tell me? 0.01. Now let me change 0.2. Let me change 0.2. Again, the same story. What is the story? You tell me. What is the story? Parameters, we got it actually. Next one is a prediction. Next one, error. Next one, error small or not. If error is a small, is it required actually? Training will be stopped. If error is a big, again, what is required? Parameter. This step is keep on, it will happen, sir. Now look at this diagram, you will understand why these many times values are changing. You can connect actually. Hold on. Now please focus. Yeah, 0 and checked actually 0. And when I say error, distance between this one and this line actually, see, automatically this line is almost reaching to this point actually. I hope you understand, man, but I will repeat one more time. Theory, but interesting theory. Just try to say intercept is slowly it is changing, something like a tortoise actually. But when it comes to m value, kundel neuntam English lo, rabbit, it is running like a rabbit actually. Good. Let's have a small theory so that I can connect actually. I'm sure you understand very well. Ayesha, very good. Until reaches global minimum value. Start with the training, we would get another coefficient and intercept. Very good. Is error value distance between the line and dots actually? Srikant, you're right, sir. You're right, actually. Now, please, you will understand these are all steps very clearly. Start with random initial value for what exactly? Parameter. Come on, read your one. Start with random initial values for what exactly? Parameter. Prediction. Do the prediction with the taken parameters. With the taken what exactly? Parameter. Good. Calculate what exactly, sir? Error value. Good. Now is cost value. Is cost value minimum value? I mean to say that is error is a small actually. If it is a small, then go to the step number 6. What is the step number 6? We have our final updated parameter. Model training is not required actually here onwards. Then go for the prediction. Now, if no means what exactly? Error is not a small. Error is what exactly? Not a small. Then go to what exactly, sir? Step number 5. What do you mean by step number 5? Update the parameter values using the gradient descent algorithm and return to what exactly, sir? Step number 2. Return to what exactly? Step number 2. Did you understand? Good. Hold on. Then like this, the cinema keep on it goes, sir. Keep on it goes actually. Let us just try to one more time. I wanted to hear from you. Step number one. In step number one, first of all, it takes parameters, man. First of all, it takes what exactly? Parameters. I would like to say initial parameters. What parameters? Initial. In second step, what exactly happened? Very good. In second step, what exactly happened? Prediction. In third step, what happened? What happened? Error. One more time. Can you please read everyone? First one is a parameters. Next one, prediction. Next one, error. Good. Step number four. You know, check error is small or not. Error is small or yeah, let me use big word actually. Let me use what exactly? Big word. Error is small or big. Good. If small, if what exactly? Small, stop training. Stop what exactly? Training. The parameters are good. The parameters are what exactly? Good. So tell me if big. When I say if small, what is small actually? Error is small. What is small? Error is small. If big, update the parameters. Update what exactly? Parameters. With the updated parameter, sir, wherever parameter came, then come and talk with me. What is the next step actually? Prediction. Very good. Next step is a prediction. Next step is error. Next step is very good, man. Hope you connected actually. The next step is tell me if small, stop training. If big, tell me again the game started actually. Update the parameters. Update what exactly? Parameters. Sir, like this, it will keep on change actually. Parameters. I'm sure today I am covering, today only you will understand. First of all, till now you have some idea what is a model creation, what is a model training. We trained many ML algorithms actually, but for every ML algorithm training backend, gradient descent algorithm will work, sir. The main motto for gradient descent algorithm also, let me reduce the error value. Let me reduce what exactly? Error value. I mean to say that backend every time the error will be calculated. Now just have to see here when I say here the error value is what exactly? 99. Parameters updated and the error value came. And again, what is the value actually? Let me tell 89. Again, what is error value actually? Talk with me. Something like a 59. Again, what is error value, sir? Can somebody help me? Something like a 9. Something like what exactly? Means these are all iterations will be happen. Trust me, in machine learning, just for here 200 iterations we are seeing in the diagram actually. But let me tell you, lakhs of iterations. Gradient descent algorithm, it will take the data, it will walk through many iterations, sir. Many iterations. Then finally, we'll get a good model. Finally, we'll get what exactly? What do you mean by good model? A model which will do good prediction. When I say good prediction, the model supposed to work very well with unknown data. What data actually? Unknown data. Also called as a unseen data. Also called as what exactly? Unseen data. Guys, are you getting? Good. Let me drink water. What do you mean by that? Hold on. Good model. That word is important, man. Even that is the next topic actually. In my free time, I used to spend with material. This, hold on, sir. There is a one folder, awesome PDFs. Can you please help me? Where is that folder? Awesome PDFs. Yeah, yeah, yeah. Here it is. Go for maths. Go for machine learning, mathematics for machine learning. I like this book very well, man. And here you can search for one word actually. Good model. I'm not sure. Case sense to exact match where, yeah, yeah, yeah. Generalize well actually. Unseen data. Sir, I'm repeating again. In machine learning, when I say good model, that model supposed to work with very well on what exactly? Unseen data, something like a unknown data, something like what exactly? Unknown data. But anyway, here remember this word actually. What is the word name? One more time, read everyone. Remember that point. I can cover later actually, and I'm sure it's a right time. I need to walk through gradient descent algorithm, remaining steps actually. It should be, sir. I understand your question. Absolutely yes, but few more checks also we need to do. Few more checks also we need to do. We need to do that is something like a underfitting or overfitting. Underfitting or what exactly? Overfitting that I'm going to cover. Don't worry. Uh, Arati, I hope you understand. Bhupesh, learning rate. Hold on. Gradient descent algorithm will take. I will come to know that point also. Good point. Where are we? And I'm sure here you will understand, sir. Now, please observe here. This algorithm finding the values of what exactly, sir? Parameters. When I say coefficients, actual of a function that minimizes cost function. Sir, only the motto will be when it comes to machine learning completely give responsible to the gradient descent algorithm. Gradient descent algorithm backend it will execute 1 lakh steps or 2 lakh steps doesn't matter, but finally it will bring only what exactly? Minimum error. What is that one? Minimum error. Keep in mind that. Now you please tell me, can somebody help me? What are all steps involving in machine learning actually? Tell me, sir. First step is what exactly? Tell me. Importing libraries. Importing what exactly? Library. Second one is a loading data set. Loading what exactly, sir? Data set. Third step is a data preparation. Good. Next one is splitting the data set. Next one, model creation. Very good. Next one, model training. Next one, prediction. Good. During model training, who is involving actually? Very good. Gradient descent algorithm involving. Along with this one more thing it is involving. What is that one? Cost function. But can somebody talk with me? What is the motto actually? The motto is minimize the error. Minimize what exactly? That's it. Apart from that, nothing. If you understand that step, done. We can close the discussion. Conclusion of the story, during training one program is involving. Best example, whenever you are writing a normal program, something like a Python program, finally to get the output actually in between one hidden program is working. That hidden program name is called as a PVM. What is that one? What is the name of, do you think, prime minister of India actually? Python virtual mission. What is the motto for PVM? Any idea? Converting bytecode instructions into machine understandable form. That is a backend process. Same thing like that. Gradient descent algorithm also will work in the backend actually. Along with that gradient, for gradient descent algorithm is a master, cost function is a junior. And cost function will ask, hey master, give me some task actually. And yeah, gradient descent algorithm will tell, I have given some parameters, do some calculation, error calculation. Cost function will calculate the error and cost function will submit that error to the gradient descent algorithm. Gradient descent algorithm will do the check actually. Is it small or big? If it is small, I hope you know the game actually. If it is the big, keep on the process will goes. Am I right or not, sir? Hope you understand. I'm sorry for saying, not we are calculating. We are not calculating coefficient value. Gradient descent algorithm will do by default. If you wanted to see that one, can I ask you one question? Let me ask you a question. Did you remember during simple linear regression, I just wanted to capture the coefficient actually. Model dot one thing we need to capture. What is that one? COEF underscore. Am I right? And model dot what exactly? Intercept. What is this one, sir? Intercept actually. Now it's a right time I need to tell. Sir, initially coefficient value is the 0. Coefficient value is what exactly? 0. And initially intercept value is also what exactly? 0. Then later on it on keep on updated actually. After updating, finally we'll get a values actually. I hope you know how to capture those coefficient intercept actually. Am I right or not, sir? Yeah. Conclusion of the story. These values in one shot we didn't get it actually. Backend keep on the process is happening. Then finally we got 2.3. Here we got something like a 1.6, something like that actually. Team, I hope you understand, sir. Can I get a response? Good. Hold on. Here onwards, whatever I'm explaining, it's a small theory. Please focus. Go back. These are all these steps not required. And for these steps, I made it here actually. If you prepare these steps, that is more than enough. You don't need to prepare this one. During interview, definitely that I'm sure 100% interview question. Please explain about the gradient descent algorithm. Then exactly these steps we need to explain. These steps we need to explain. Now look at my screen. There are a few more terminology also you need to understand. And hold on. Go back to the diagrams. I will come back. Hold on. Yeah. Follow the below images. What is images? Just to try to understand the below images for better understanding. Try to understand the below images actually. Initially, what is the value, sir? 0 and 0. When the values are 0, 0, I would like to say this is the line was created actually, but this line is what exactly? Can I say this is the best fitted line? No, this is not a best fitted line. And kindly please remember this one. Take this one. Now I would like to say this is the error value. Distance between the line and these points is called as what exactly? Error. The error is a big error actually. Error is what exactly? Big error. Then the values got changed. Once the values got changed actually, the position of line also changed. Please look at that one. Previously the position of line is very far actually. Now the position of line is what exactly? Near to the data. The position of line is the near to the data because of these two values. Can I say that one? Can I say because of updated parameters actually? Good, very good. And again, the position of line is almost near to the data because of what exactly? Updated parameters. What exactly, sir? Updated parameter. Like this, the process is keep on happening. And please observe this one. And anyway, I hope you know the already the diagram actually. Am I right or not, sir? Now, finally, I would like to say, when it comes to 200th iteration, the gradient descent algorithm came across. Don't think like gradient descent algorithm never look at the data, never look at the line actually. It will always look at the error value. What value actually? Error value. And one more point you need to remember. Error never be, one more time, error never be 0. That point is important. If cost function is telling error is the 0, gradient descent algorithm will scold actually. Are you fine? Are you sleeping or what? Something like that actually. Keep in mind that. Go back. Now these are all steps, man. For sure, even if you didn't remember, these are also no worries. But till now, what I have explained, you need to understand. Now, the topic name is called as a convergence. What is the topic name? Convergence. What do you mean by convergence? Reaching the point which gradient descent makes very small changes actually. First of all, what do you mean by gradient? Any idea? Gradient means what exactly? Good. But it's okay, good. But we are just asking English meaning actually. What do you mean by gradient? Any idea? Yeah, very good, sir. Gradually. What is that one? Best example. From here to Kokatpalli. I'm going by walk actually. I'm going by what exactly? Walking. Gone case man. That is called as a gradually, slowly I'm moving. Now here also, error also supposed to move slowly step by step. Now what you need to understand, sir, initially what is error value? Tell me, sir. Suddenly it will not decrease to 10.5 actually. Don't think like, from 100 to which step it came actually? 10.5. No, sorry for saying this is invalid actually. Error never reduce in a straight away, something like that. Slowly by slowly, that to descent means reducing. Descent means what exactly? Reducing. Ascent means increasing. That descent opposite word is a ascent actually. Machine learning algorithm, backend it will use gradient descent algorithm, but not gradient ascent actually. Gradient what exactly, sir? Ascent. Come on, hold on. The first one is simple linear regression. Backend it will use what exactly? No, gradient descent algorithm. Hey Daniel, what do you mean by gradient, boss? Gradient means, gradually. Gradually, also called as a slowly. Slowly it will start change actually. Now descent means reducing. Descent means what exactly, sir? Reducing. You have to remember like that. Descent means reducing. Reducing, also called as a minimizing. Reducing is good word actually. Instead of minimizing, reducing, it is reducing slowly. When I say till at what level it reduces, till at what level it reduces actually. Until minimum value. Until what exactly, sir? Minimum value. I hope you understand very clearly. But let me tell you, this is the good pattern. I mean to say the initially 10 value. Initially, what is the value? 10 value. Next one is 99.9. Yes, good value. Next one is 99 point something like a 5. Next one is 95. Next one is what exactly? No, 95. Next one is a 89. This is just for simplicity, I'm telling. 88. I hope you understand what exactly happens, sir. Can I say it is reducing actually? Tell me, boss. Reducing. Error value. This is good pattern. 88. Next one is what exactly? No, 78. Next one is a keep on. Lot of iterations are happening. Like a 200 iterations are happening. How many iterations? Finally, we came across the error value is a 1.5. The error value is what exactly? 1.5. I would like to say 100. It is a big error actually. It is what exactly? Big error. If the error is big actually, what exactly happened? Parameters are getting updating. Then with that prediction, then again calculate the error value actually. Error is again bigger value. Then parameters are updating. Prediction, error. Again, it is a bigger actual. I hope keep on it is happening. Now, can somebody tell me error is a big value and error is what exactly, sir? Small value. Reaching this minimal position is called as a convergence. Reaching this minimal position is called as what exactly? Convergence actually. Kind of some technical words, those are all, but keep in mind that. Yeah, hey, one more point is important. It does not mean that it has reached the optimal result actually. Sir, let me tell you, the best error is a zero. The best error is what exactly? But let me tell you, never error never be what exactly? Zero. But it is almost 1.5. It is almost near to the error value. 1.5. It is almost what exactly? Near to the error value. The process behind the gradient descent algorithm, some what I can say, a kind of some cost function will give what exactly, sir? Any idea? Error value. And when I say cost function, can you tell me in regression cost functions actually? Any idea? MSC, MAE, RMSC. One more time. MSC, MAE, RMSC. I mean, gradient descent algorithm is the algorithm that finds the best fit line for the given training data set. If you calculate for every value for M value and B value, then we'll get what exactly, sir? Am I right or not? I hope you understand. Go back. Now, initially, with the parameters it is doing prediction. With the prediction what we are getting actually? Error value. When I say error value, MSC value, what value? What do you mean by MS? Any idea? One more time. Yeah, good. Now read this point, you can understand. If you calculate for every value of M and B, M means coefficient, B means intercept, we'll get what exactly? MSC value. If you plot M value, B value and error value, if we plot, generally we never plot. Trust me, I'm repeating again. This is just a theory. During interview, you no need to, I mean, during while working in a real time, you no need to work on this one actually. If you plot M value and B value against MSC, then we'll get this kind of below image actually. Sir, gradient descent algorithm, and I would like to show always kind of some bowl shape actually. What shape actually? Bowl. Let me show you. Gradient descent algorithm. Gradient descent algorithm. Click on this one. Click on images actually. Look at this one. Definitely somebody will explain bowl shape actually. Just try to see. This one is the bowl shape. Here also bowl shape. These are all actually. Just try to see, man. This diagram pretty good. Learning step by step it is moving actually. This is something like you are living the small ball here. Step number one. Keep on reaching to what exactly? Minimum value. Machine learning mastery. There is a good website actually. Yeah, I like this one, sir. Bowl shape actually. I mean to say that assuming that let us just try to take a small ball actually. You can just try to leave at edge. Then what exactly happen? Slowly by slowly, it will move on, it will move on, it will move on. At finally, it will reach the position where exactly a stable position actually. Error also same thing like that. Error also same thing like that. I'm sure. Yeah, this website is really very good, sir. If you're having a time, you can walk through Machine Learning Master. I hope I already explained previously. Let's move on. There are some best authors for data science. I used to follow. Go back and kindly MSA value 0, 200, 400, 600, 800. Plotting the plotted value actually. Here we'll get an image which is like a ball. And we need to start some value for M and B. Usually, let's start from what exactly? 0. Come on. I hope you understand. Now, B value with respect to cost and M value with respect to what exactly? Tell me, sir. Cost only. Cost only. And always the error should be here actually. Error should be here. Can I ask a question? Why it is not touching X actually? Any idea? Come again? Error never be. That's why it is not touching. You have to remember that one. Okay. All right. Now, see, just now we have seen. These are all data points actually. Kindly please walk through this theory. Yeah, these are all images we have already seen actually. Move on, move on. If you understand first to top 6 points, that is fine, man. Sir, hold on. Look at my screen. Look at my screen. This is a bit important. First of all, look at the diagram. Look at the diagram. I need your attention actually. Please. Sir, here what exactly happened? Assuming that here the error value will be something like started with 100. Started with what exactly? 100 actually. Just imagine the error value is something like here is the minimum value. Error value when it is reducing, don't think like it will reduce with the fixed steps actually. First 100, next 90, next 80. Next value tell me 70. Next value 60. Next value. Don't think like that. Whenever the error is reducing, gradient descent algorithm will apply some condition to cost function actually. Cost function also will follow the some rules actually. Whenever the error is reducing, keep in mind that it never be fixed steps. It never be what exactly? The problem with the fixed steps will be what exactly happen? Yeah, talk with me. From here to here it is okay, sir. Here to here it is okay. Here to here, maybe the distance between here to here is the same actually. No doubt at all. Here to here it is not the same. Then it is taking an extra step actual. Then what is the problem here? Any idea? We are missing the error. We are missing the minimum error. We are missing what exactly? Did you understand? I need a response, man. Did you understand or not? I hope you understand. Right? Good. Now, if you follow the fixed steps, then we'll get the below image actually. By following this approach, we may miss what exactly, sir? Global minimum value, minimum value, minimum value. This approach is not what exactly, not going to be well. Now the next one, sir, this is really, just try to say like this, like this. Initially, it is the bigger step. It is okay. Then when it is moving on slowly by slowly, it is reaching something like this actually. I hope you're getting. It's a right time. Even I need to show small diagram. Gradient descent algorithm. Let me drink water and look at this image actually. And are you able to see there is a red dot? It is moving on. You're able to see, right? Huh? Just you're able to see. Initially, the dot is falling here, and next step is here, next step is here, next step is here. Slowly by slowly, it is reaching and it is stopping. But it is not moving here actually. Please observe here. Are you getting? Tell me, man. Good. All right. These are all showcase not record actually. And Sir, let me tell you. You may ask a question, sir, how it comes to know in between the how the error value is moving here to here actually. In a math, there is one topic actually. The topic name is a theta value. What value? Backend it applies some math actually, and it is moving on to this minimum value. You no need to focus as of now. Being a junior, you no need to focus actually. Now look at my screen. Sir, this is the big learning rate. Learning rate in the sense, here is a one step, here is a one step, here is a one step. Not a good practice actually. Small learning rate also not a good practice. I mean to say that the change is the very big. I mean 100, 50, again 1, again it goes to minus actually. That is not a good practice. And even the small change is also not a good practice actually. When I say small changes, 100 to 99.000.9. Again 99.000.1, again 99.000.1 actually, something like that. But instead of that one, it will move on to the some optimizer line actually, right? Anyway, I understand these are all diagrams, you don't need to focus. But let me tell you one point actually. I need a response from you. Did you understand these 6 steps or not? I will give a small recap, just a matter of 2 minutes actually, then we can close this discussion. Come on, in this revision you need to respond actually. First step is, tell me, sir. Parameters. Next one. Tell me. Next one. Come again. Okay. If error is small, then can I write one statement? Parameters are good. Then no training is required. No, training is not required. Training is not required actually. Not required. And here I can say not required. Model is ready. Model is what exactly? Ready. Good. Next one is, if error is big. Tell me. Parameters are not good. So update the parameters. Update what exactly? Update the parameters. With updated parameters, what we need to do? Yeah, again the cinema, again the movie started, sir. Prediction. Next one is a error. Sorry, I'm not writing. These are all things. I'm sure you understand very well. Am I right or not? But like this. For every algorithm, backend, these are all steps are happening, man. Keep in mind that. Now, by consider that, I hope you understand. Let me move on to the next topic actually. Why I entered into here? Okay, good. Sir, small update. What is update? You tell me. Tomorrow we have a session. The update is what exactly? Tomorrow we have a regular session. No doubt in that actually. If you're not, if at least one person also came, I can tell you, sir. If you're not coming, I will tell to chairs also. That is still fine for me. Okay. Why? Because hold on. Small. Same time. No change in that. If anyone is unable to attend tomorrow's session, I'm sorry, I cannot provide video recording. That I'm very clear actually. Okay. All right. Let's move on. Arati, let me plan. Hari sir, sorry, since long you are following actually. Maybe I already helped to 2 members yesterday. Maybe let me help you guys also. Mock interviews also I can take, sir. I appreciate your patience, please. Come on, 5:30, machine learning. What is the next topic, sir? Left hand side, did I miss anything? Introduction, terminology, data and ML, I covered, right? Tell me. Yeah. Next one is learning function, types of models. You tell me your types of models. Very good. Tell me, supervised, unsupervised, reinforcement learning. Reinforcement learning is completely related to the AI, sir. A kind of, agent. And one more point, agent, environment, points. These three things will involve actually. Next one is the life cycle. Train and test data sets actually. Sir, let me tell you. I would like to tell one point actually. I'm not highlighting myself. No trainer never make it. This one is a separate topic. They will explain directly one step actually. That step is a train underscore test underscore split. That's it. They can close the discussion. But we almost minimum that to the topic I have covered. I still remember Saturday I covered actually. I have taken almost 40 minutes to explain about that topic. Am I right or not? Please understand the importance of the topic. Very, very important actually. That too, Python revision is happen. We are calling a function which is returning how many values? Four values. In Python programming language, functions part number one, last topic, the topic name is a function can return what exactly? Multiple variables. Keep in mind that. That's the interlink actually. During Python discussion, I cannot highlight, but during machine learning, I can highlight. I can correlate actually. Sir, are you getting? Good. R value, simple linear regression we done. Example we done. 9.2, I have given assignment for you. God knows either you done or not actually. Am I right or not, sir? Tell me, am I right or not? Good. Only God knows. Next one is a polynomial feature. Multiple linear regression, pickling and unpickling. Are we done? How many ways actually? Two ways. First one is by using pickle module. Second one is by using nice man. Second one is by using job. Two functions. Tell me two functions names. Load and nice man. Very good. You guys are in the flow actual. Next one, save the model by using joblib and pickling. Cost function, regression cost function, dummy variable, gradient descent algorithm. Khatam. We done today actually. Logistic regression and decision tree, confusion matrix. Hold on. Bias variance trade-off. Now I wanted to start this topic, man. But in between decision tree we done, random forest we done, k-fold we done, SVM we done. Oh, this is the diagram. K means are we done? All right. K means clustering. K means clustering. K means clustering. Did I show one diagram actually? A fun image. Did I show that one? Let me show you. I need your help actually. Definitely in my tab, there are some fun images actually where the tab is available. Can somebody help me? Yeah, here fun. Yeah, fun images. Look at my screen. Everybody, please look at my screen. I hope I'm sure this I already explained actually. There are some points. You know, the manager told clean the data. He deleted the data. Then what exactly happened? When they asked you have to clean the data and you cleaned it all of actually. Don't apply DEL operator. What operator? Gone actually. You know, it will be deleted completely. Tell me, sir, is it cupcake or cute dog, man? I like pet animals, boss. I like pet animals. Machine learning. Let me see who you really actually. Who is the backend talk with me? Statistician. Now keep in mind that machine learning backend is a mathsman. Machine learning backend is what exactly? We are really lucky. In olden days, who can do prediction? You know, those who done PhD in a maths actually, they used to do the prediction. Those who done PhD, they used to do the prediction actually. Luckily, we have a Python libraries. We have what exactly? Python libraries. Python libraries indirectly hiding all math and call me the function, I can give you the result. Something like that it is telling actually. Am I right or not, sir? Good. Now, what I wanted to show you now, there are few more images. Not this one, not this one, not this. Arey man, seriously? Yeah, yeah. Not this one. Come on. Oh my God. Seriously? He is teaching Python to Python to Python. Who are all scared about the snake, sir? Are you scaring about snake actually? I will run away. You know, basically I'm from village. One day I have seen very near, sir. Come on, please. There is. Yeah. Look at this one. This is what I'm looking for actually. Please look at this one. Clustering means what exactly happening, you know, assuming that there is a pool actually, a different balls would you have a separate person, separate, make it something like a group of balls. Can I say this is the clustering? Yeah, I mean to say that, you know, K means clustering. A kind of some different classes actually. Kind of what exactly? Different classes. Not much fun, but it is okay. The comparison I like very well. All right, let's move on. I would like to start the topic. The topic name is called as a bias and variance. Good. Now, come on. I just need a response from you. The topic name is called as a bias and variance of variance trade-off. These are all different words, man. First of all, bias is a different word actually. Variance is a different word. Trade-off is a different word. These are all things actually. Do you know about the trade-off meaning? Any idea? Hmm? Good. We'll see. Step by step, we'll see. Come on. I need a help, man. First of all, let me repeat again. Bias means error. Bias means what exactly? Error actually. No doubt in that. Variance also called as error. I will tell you when we can see that variance error. Repeating again. Bias also called as what exactly? Error. And variance also what exactly? Error actually. Repeating again. Variance means also called as what exactly? Error. Hold on. I need your help. Tell me steps. Importing libraries. Second one is a loading the data set. And third step is a data preparation. Will you forget this step in your lifetime, sir? Tell me. Preparation. Few guys are telling yes, actually. Splitting the data set. And the fifth one is a model creation. And the sixth one is a model training. Seventh one is prediction. Seems to be this is for my practice actually. Good. Backend who is working? Gradient descent algorithm. Okay, all right. Gradient descent algorithm work. Backbone? Cost function. Cost function will give what exactly? Error. There are two types of error. The first one is a bias. Next one is what exactly? Now I hope you can connect actually why I'm explaining the topic by topic now today. I'm sure you will understand. Today is the right time actually. I'm repeating again. Look at my screen. Gradient descent algorithm depends upon the cost function. The motto for gradient descent algorithm is let us minimize the error. Let's minimize the error. Let's minimize what exactly, sir? Error value. But when you're talking about the error, man, there are two types of errors. There are how many types of error? Two types of error. The first one is a bias error. Next one is a variance error. What do you mean by bias means what exactly, sir? It's a very simple actual value minus predicted value. Talk with me. What is a bias error? Actual value minus predicted value. One more time. Actual value minus predicted value. What do you mean by variance error? If you wanted to understand this one, go back actually and just try to close your eyes and I will explain one small scenario. I will recall. Then once you understand that one, then you can easy to understand this. Read everyone. First of all, read this word two times actually. First time read everyone. Variance. Last time, hold on. First of all, what do you mean by variance? Change in a training data set. Change in what exactly? Train data set. Repeat one more time. Change in a train data set. One more time. Hold on. Go back and let me recall one of the let me recall one of the example. My father started training, sir. First of all, we are two sons to my father actually. My name is Daniel. Another name is any idea? Prasad Kumar. In childhood, I hope in a family there are two sons, either one son or one daughter actually. Always fightings will be happen. What happen? Fightings will be. Now let me tell you, my father decided, can somebody talk with me? My father to train Daniel regarding what exactly? Any idea? Recognize cat and what exactly? Cat and dog. Good. Sorry. Cat and dog. Then my father have collected how many images? 100 images. My father have collected 100 images actually. Hold on. Remember, 100 images. Then the data splitting started. The data what exactly? Splitting started. What is the splitting ratio? Can I ask a question? Have you ever seen this kind of example? But the total machine learning depend upon this example only. If you remember this one, the entire topic you will understand actually. Now with the 70 images, my father, what exactly training started. What started, sir? Training started actually. Training started. Frankly speaking, training really it is going fine. It is going what exactly, sir? Fine actually. And almost my father started giving training 59th image. Which image actually? 59th image. Hold on, hold on. Suddenly my brother came. Who came actually? My brother came. My brother, what he doing, my brother is a Prasad Kumar. He is telling to my father actually, father, we'll do one thing. Anyway, you are training to my brother, right? And let me give few more images. Let me give what exactly? Few more images. Then my brother have given 10 images actually. How many images he has given? Already I'm in frustrated with 70 images. How many images? My brother is bringing how many images? 10 images. Then yes, my father feel really good actually. Now 70 plus what exactly, sir? 10. Now total how much data set actually? 80. But let me tell you, my father done a small mistake. What my father done, in this 10 images actually, my father started training. What is the training actually? Cat and dog, right? But unfortunately, my brother bought donkey images actually. What images? Donkey images. I'm repeating again. Again, the example will be my father started training data splitting 100 70-30 ratio. 70 what exactly? 30 ratio. He started training. My father started training. Almost it is going fine. 59th image. I'm starting counting. Next only 11 images actually. After that we can close the training. But in between my brother came. My brother is telling, dear father, and I brought few more images actually. We need to train our my brother very well actually. And frankly speaking, my brother and myself always we used to quarrel in childhood actually, but not nowadays. But let me tell you, my backbone is my brother. Good. Now let me take few more images, 10 images actually. Then total how many images actually? Talk with me, sir. Yeah, no doubt at all. You know, during what exactly, sir? Training, data set changed actually. Data set what exactly happened? Changed. Due to this one, we got errors. We got small errors actually. We got what exactly? This is called as a variance. This is called as what exactly? Variant. Sometimes training data set can be updated. I'm repeating again. Sometimes training data set, what exactly? Can be updated. Because of this updating the training data set, we may get a error. That error name is called as a variance. That error name is called as what exactly? Variance. Now you talk with me. Bias means what type of error? Difference between actual value, predicted value. One more time. Difference between actual value, predicted value. But variance means what exactly? Sometimes training data set can be updated actually. Because of this one, we will get an error. This error name is called as a variance. Remember, these are all terminology. Now, let me start the discussion. Yeah. Bias is the error difference between predicted value and bias is the error. It is a difference between predicted value and actual value. Variance is the error that occurs due to small changes in what exactly? Did you understand? Good. Next one. First of all, remember the bias and variance provide information to understand the performance of ML algorithm while doing prediction. First of all, keep in mind that error means it is the information to the algorithm. It is what exactly, sir? Information to the algorithm. Did you remember? There is a diagram, the diagram, assuming that this is the mango tree actually, assuming that this is the mango tree. Let me just try to take this one. And here having some mangoes. Just imagine. Now I'm standing here. I'm standing here. I I have thrown to the stone actually. Now let me take, this is the stone. Definitely no doubt at all. From my stone distance to this, mango distance, this is called as what exactly? Error. This is called as what exactly? No doubt in that. But let me tell you, this error is giving information to Nirikshan. Information to whom actually? Nirikshan. Next time, what is the angle? What is the speed? What is the direction? Indirectly, the error is guiding me. Same thing like that in machine learning also, error will guide to the ML algorithm. Error will guide to what exactly? ML algorithm. First time, let me repeat again. After a long time, I'm explaining the theory. Everyone is so much interested actually. No one is not sleeping. I'm sorry for getting. Seriously, I'm telling. No one is not sleeping. Okay. Good. I can appreciate you. Raise your hand, sir. Who are all sleeping? All right. Just kidding. Come on. Now read this point. Read this point. The bias and variance provides what exactly? One more time, sir. Information to whom actually tell me? Machine learning algorithms while doing prediction. Indirectly, bias and variance are information to ML algorithm. Either your algorithm is really good algorithm or else not up to the mark actually. The goal of any supervised learning algorithm, I hope you know, in a supervised learning technique, an algorithm learns a model from the training data actually. Read the point, sir. The goal of any supervised learning algorithm is, read everyone, finding the best mapping function in between the target function for the output variable to given input variable actually. Can somebody tell me where we covered this point? Any idea? Exactly this line where we covered. Finding the best mapping function, also called as a target function for the output to input. It's okay, no worries. And I need a topic name actually. Even if you didn't remember, do one thing. Just try to learn this point actually. Go back and I already covered. You need to walk through that one. Yeah, please observe this one, sir. First of all, what do you mean by where I covered? The topic name is called as a learning function. What is the topic name? Learning function. There I covered actually. Important. You need to remember. Error means some wrong calculation. Error means what exactly, sir? Am I right or not? Some wrong calculation. Error can be small error or what exactly? Big error. Small error can be acceptable and big error should be. Don't think like big error we have to ignore actually. No, no, no. We have to minimize. If you are getting big error actually, best example. There is a son. He is doing lot of mistakes actually. Parents never live. And parents will slowly by slowly they will tell we should not do like that, we should not do like that, we should not do like that, something like that. Conclusion of this story, small error can be what exactly? Acceptable and big error should be minimizable. Good. Prediction error. Prediction error means we made some prediction, but there are some errors are existing. The prediction error for any machine learning algorithm can be divided into two parts. The first one is a bias error, next one is a variance error. Tell me, sir, first one is a bias error, next one is variance error. Hold on. Ignore this discussion. Ignore in the sense I will cover. Hold on. Even hold on. Variance also you can hold on. And sir, this diagram is damn important, man. During interview, if anyone is asking, explain about the bias and variance means you need to draw this diagram. Very, very important. Okay. Let me explain very clearly. This diagram is talking about what exactly, just look at my screen, everyone, please. Sir, simple. There are two columns and two rows. There are how many? Two columns and two rows actually. Good. And now B first or V first? Tell me. B. Which one is first? B. Then no doubt at all, left hand side, the starting position is what exactly? This is called as a low bias value. What is this one? Low bias value. This is called as a high bias value. Tell me, sir, one more time. What is the first one? Low bias, high bias. One more time. Low bias, high bias. The next one is a low variance, high variance. One more time. Low variance, high variance. Sir, let me tell you, every algorithm may face these four phases. Only these four, actually. Any one of. Right, good. But which one is really good, If any algorithm having low bias value and low variance value, no doubt at all that algorithm is really good, actually. Hey, this is something like a archer who is hitting the arrows, actually. Something like a target. Can I say that one? I would like to say the red color, what is available called as a target. The archer, what he can do, he can take the arrow and he can shot the target actually. Now, can somebody tell me if any algorithm having low bias in the sense small bias value. What bias value, sir? Small bias value. Low variance is what exactly? Small variance value. Then that is really what exactly, sir? Good algorithm. That is really what exactly? Good algorithm. Then next one. Three more, three more pages also would you have. An algorithm having low bias and high variance actually, frankly speaking, that is okay. That is what exactly? Okay, but not up to the mark actually. Okay. Here out of 100, I can give 99 actually. And here out of 100, I can give some 80 marks. How much marks actually, sir? 80 marks actually. But let me tell you, high bias and next what is the combination? Low variance. Sir, sorry, not up to the mark actually. This algorithm is what exactly? Not up to the mark. And this one also not up to the mark. And even this one also not up to the mark, but it is okay, acceptable actually. Out of all this discussion, which combination is really good actually? Low bias and what exactly? Low variance. One more time. Low bias and low variance. Hold on. Damn sure interview question. Please explain about the bias and variance. Means first you need to draw this diagram. And many of the students, variance they are writing here, bias they are writing here actually. Remember one thing, B first. Which first actually? B first. Low bias and high bias actually. And low variance and next one is what exactly? High variance. And it's okay. Let's continue this one tomorrow. But this diagram kindly prepare before you are coming to the tomorrow session. We done for today's session. Tomorrow, do you have a session? Yes, sir. Please. Thank you. We done for today's session. I can upload the running notes. Arati, simple. Do one thing. We can store insert string actually. You can ping me. I can help you. But we can do very easily. There is a collections module in Python. By using that, this we can achieve very quickly. There is a collections module. By using that, we can get this one very quickly. If you want, you can try. In Stack Overflow also, you can get the same thing. Okay. All right, man. Fine. Then let me upload the material, sir. Yeah, boss. There are many ways, but I'm repeating again. There is a collections module in Python. By using that, we can do very quickly. All right. Thank you.